So we're going to focus today on finding the locus of the object. So a locus is a set of points that satisfy a particular condition. Okay, so we'll see locus pop up a lot in inequalities when we go to the graphing one, and we can say, okay, inside here is where it's going to satisfy. But we're going to talk about this in terms of our constructions. So the plural of locus is loci, and are the traits associated with the constructions. So I've kind of went through some of these while we were going through constructions, but now to sum it up and put together a bunch of them together. So here we have the types of locus. So for the locus for a point, or is the circle of the radius given. If you have a line drawn, the locus is this sausage shape to the right here. Okay, so it would be the radius away on both sides of the line, and then when you get to the end, well, it would kind of trace out a little bit of an arc like we've been doing with our constructions. We have the perpendicular bisector, which we've done this whole time, and when we talk about the locus, we just want to know, okay, does this satisfy? Well, we're talking about the locus is of the points of equidistant from the endpoints of a line. So sometimes you might be asked to do a construction in terms of a locus. So talking about the locus, can you show it through your constructions? Then you have angle bisector, which is the points equidistant from two lines. Well, that's just that entire line that is used to bisect, or that we bisect that angle with. So it's all along that line. We'd have those points. That would be our locus, is along that set of that line. So a lot of these is just a line. Sometimes it's an area. So here we want to draw a line 5 centimeters long and draw the locus of all points that are 2 centimeters from our line. So to do this, I am going to first draw my line 5 centimeters long as such. Then I know that my locus is a set of points that are 2 centimeters away from our line. So before I start using this, I'm going to set our compass. Oh, I've set it at 2 centimeters. Okay. So what I'm going to do here is put it on the tip here, and I'm going to draw just around like that. And similarly from the other side, flip it around and try and draw this almost a semicircle around here. Okay. Now we want to indicate where 2 centimeters is roughly with our ruler. Okay. So I'm going to do 2 points on either side. That way we know where we're kind of lining up with our semicircles. So actually that point's going to line up quite nicely. So I'm going to draw a line connecting there and there. And similarly on the bottom part, we can just run it through and we can just end up taking away. So this would be our locus. So the locus of all points that are 2 centimeters from our line is this entire shape. And so when I say the entire shape, it's this, right? It's this, anything that lines on that line. Not inside, not outside, just along that line. So, question 2 now, or example 2, I should say. Just letting my computer think. So, example 2, let's get rid of this stuff. Mark 2 points on your page 4 centimeters apart. Okay. So, first off, like I said, don't skip yourself way too ahead, read too much. 4 centimeters apart. I've got my 2 points. And a couple other points from my hand hitting it. So label them A and B. Right. A and B. So construct the locus of all points that are equidistant from A and B. Well, what is that, right? What's it actually asking us to do? Well, this is where you have to start remembering some of these traits. Well, equidistant, right? All the points that are equidistant is, well, it's from the endpoints. So if it's from here, so that's equidistance from those 2 points. So that means that we'd have to draw a line between them, right? Because that's just basically talking about our endpoint. So if we do that, now we can just simply grab our compass, put it on our line, extend it out, and we can draw an arc from B, and then keeping the same radius, do the exact same thing on A, and lastly, take a straight edge, and we can draw our line, ensuring it goes through those points that we have just indicated. Right. So all along that line is our locus. So you could just say locus. Sorry, I think getting a little slow now. So locus is this line, right? Example 3. So we want to draw 2 lines that are 70 degrees apart. So that just means a 70-degree angle. So you draw this. Because it says draw, keep in mind that we use our protractor. So this is why I'm using it simply like this. And we've got our 70-degree angle. Okay. So we want to find the locus of all points that are equidistant from both lines. Well, if they're equidistant, that's the line going through the middle, right? So that's our angle bisector. So, like I said, you're going to be asked to do constructions through having to do your locus. So there, we've set it up. It pretty much brings together everything that we did from the beginning, drawing triangles, to now where we're doing constructions, finding the locus, and commenting. So here, we've placed it here, keeping our same separation, make an arc, put it on our other point on the line, and we're doing another arc so that they intersect. Once you've done that, grab your straight edge, connect your tip of your angle and that intersection, and you have done. So you could say that the locus is this little line here. Okay. So here are 2 questions for you to practice. So pause your video now. When you're ready, press play. Right. So let's look at question 1. It says that we're going to mark 2 points that are 4 centimeters apart on our page. So that means we have 1 point here, another point here. Right? So we've marked it 4 centimeters apart. Find the locus of the points 3 centimeters from each point. Indicate the area of overlap by shading it in. So what's it actually asking us to do? Is pretty simple. So first off, we need to find 3 centimeters with our compass. So remember when we're measuring that, we just put a ruler on the page and use our compass over top. So we have 3 centimeters. So here, it's a circle, right? Around a point, it's just a circle with the radius specified. And we're doing the same thing for the other point. So the locus is those circles, right? And then the last part it asks is ask for the shaded in area. So this shaded in area here is what they've asked for. One thing I want to kind of mention is this is what I meant when we talk about locus and kind of inequalities and shading in areas of overlap, right? So it's not exactly the same, but it's kind of specifying boundaries. That's what I've always envisioned locus to be, is kind of specifying a boundary to a problem. Also noted as boundary value problems. So draw a line AB and find the locus of all points that are 2 centimeters from it. So that's like our example before. So we're just drawing a line So depending how long your line is, could change the size, change what if it looks like a sausage, or it could just look almost like an ellipse. But here now we're just taking our compass. So take your compass, put it on the line, and then measure out your 3 centimeters. So we can put it on our endpoints and check. So there. And we can draw our circles around here, or our half circles, or semicircles, or hemispheres. Lots of different ways to talk about half of a circle. And it doesn't matter if you draw too much like I just did, because afterwards I'm just going to connect kind of the tops of our circles, right? Because that would be that. And then similarly, we can do the exact same thing to the bottom. So at this point, if you find yourself pretty happy with Locus, you may stop. If you do want, there is an additional question, which I think is kind of hard. It's the hardest thing you can get. So if you want, can try it. But I will go. You can pause the video, and I'm going to go through it again right now. Right, so we're going to construct this triangle. I'm going to start off with our biggest measurement for the ruler. So we have to go from here, and we're going to draw out 6 centimeters, right? So I'm just going to change my line to be a little bit skinnier. Okay, so now, that is our 6 centimeters done, right? So now, how am I going to construct this triangle? Well, let's just find our measurements. So we want 2 centimeters. So get it out and put it to 2 centimeters. Make yourself an arc. Right. Similarly, we can do the same with 4 centimeters. And we can make another arc. So that actually doesn't help us too much. We just know anywhere along there is 2 centimeters on that first arc, as you can see, right? So all we really want to do, and this triangle probably won't work out, actually, based on the measurements, is we'd actually want those two to be touching. So the fact that they can't touch, this question isn't actually a very good question, in my mind. Because we actually wouldn't get a triangle. So, kind of forgetting about that for a second, what I'm going to do is simply draw a triangle down here to get the point across. So for proof of concept. So now we want to do 1.5 centimeters from any of the sides. So to do this part, it's very similar to what we did the other ones. So I think I understand where this question was trying to go. It's trying to get you to do constructions and constructions and locus at the same time, but it just wasn't put together well. So don't worry if it didn't work. I more so wanted to include a question like this for kind of proof of concept of when you'd actually use this. So there, we have it set at 1.5. And now all you want to do is place it on the 3 points of the triangle, kind of draw a semi or an arc around them. Right? It doesn't have to be all the way around. Some of you may see where this is how we're going to get our lines already. It's really similar to doing our sausage shape, only instead we're doing it with this. So I'm actually going to go back and draw it all the way around because it says from any of the sides. What I noticed, I was thinking about this as from the one side. Well, who says we can't have it from the inside, right? So there. We've got these 3 symbols here, right? So now this is where you're going to grab your straight edge, and you find your outermost point, and you connect your outermost points so we can find our locus for the outside. And similarly, we're going to do that for the locus for the inside. Okay? So for the inside, we do end up having to use our ruler a little bit because you kind of want to find some places that could be or that are 1.5 centimeters away. So that would be there for that one. Then here, 1.5. Oh, so if you look, that ends up just being our locus, ends up just kind of being a point right here for the inside. So normally you'd get a shape kind of like that on the inside. So you'd get a kind of an A, like a bubble letter A if you're trying to draw one without the bottom to it.